Dear students, greetings. In this video lecture, we are going to discuss about error detection method using cyclic codes. Okay, what is cyclic code? How it is used to detect the error? We are going to discuss this lecture. This is the continuation of second unit error detection method. In error detection method, how the cyclic codes are used to detect the error, we are going to discuss in this lecture. The outcome of this lecture is you will be able to detect the error using cyclic codes. Okay. So before going to discuss about cyclic codes, some methods is there to identify the error and using the cyclic codes or redundant codes. The Hamming distance between two words is the number of differences between the corresponding bits. So Hamming distance method also used to find the error or detect the error in transmission data. So what is Hamming distance? Distance between the two words is number of differences between the corresponding bits. For example, find the minimum Hamming distance of the coding scheme. We first find all the Hamming distance. The distance between this means what is the mismatching is there. So example, how many bits are mismatched, that is the distance. So we can apply this here. All inputs are 0 and then how many bits are changed? 1, 2, 3. 3 bits are changed. So the distance is 3. Here again 1, 2, 3 changed from this board, that is 5. Okay, same like this here 4 bits. Here 0, 1, 0, 1 is there. 0 is changed, 1 is changed, again 1 is changed, 0 is changed. So 4 bits are changed. So the distance is 4. Now, after calculating all the distance, which is how the minimum value, that is the D minimum, distance of minimum, Hamming distance, minimum value. So what is cyclic code? Cyclic codes are special linear block codes with one extra property. What is that extra property? In a cyclic code, if a code word is cyclically shifted, that is rotated, the result is another code word. Okay. So once identifying the code word will be rotated, then it will be considered the another code word. Okay. That's the advantage of cyclic code. So in cyclic code, how the data is transmitted. For example, this diagram, you just see this diagram. Here, data word is there. Already we know data words. Okay. So this data words, 4 bits is there here. The data word how 4 bits. A0, A1, A2, A3. Then added extra some redundancy bit. Why? Because the generator will generate some codes, that is code word. Okay. So what is the code word? Data word plus redundancy bits. So that is considered the code word. So here 3 redundancy bits is added, 4 data word is added, totally 7 bits are transmitted here. Okay. So what will be how the generator and checker is working? Some common code we need. That common code is considered the divisor. Both the side, both the generator and checker use the common divisor. Both encoder and decoder, we need the common divisor. So after receiving this 7-bit code word, then checker will check that value. So how it will be work? Based on the divisor value, same divisor it will be used, then it will be removed the syndrome value. So finally it is getting the data word. Okay. So if it is accepted, that means there is no error, otherwise it will be discarded. So here you see that simple examples here. This is the divisor. It's a common to both sender and receiver 1011. Here data word is also 1001. Okay, so data word is 1001 and divisor is 1011. So how we can do it? So we can see that the divisor, okay, the number of bits in the divisor minus 1. That we have to add the extra bits. How many bits we have to add extra? That is augmented data word, dividend. So how we can find it? Number of data bits in the divisor minus 1. Okay, so here number of bits are 4, then 4 minus 1, so 3 is the answer. So 3 extra bits we have to add while doing the division operation. Okay, so this is the data word, this is the divisor, we are adding 3 extra bits. That is extra bits is 0. Okay, so this is the divide and value. So how we can do it? Divide and, so what is the first value? 1 is there. Here you can check which is the first value. So one first value means you will divide with 1. So if we are multiply with 1 means the same value we are getting 1011. So first bit should be same. If 1 means you multiply with 1, if first bit is 0 means you multiply with 0. So here first bit is 1. So you can multiply with 1. 1 into 1, 1. Here 1 into 1, 1. Okay. 1 into 0, 0. Again 1 into 1, 1. Again 1 into 1, 1. Okay. So first bit 0. So now we can apply the XOR bit. But we have to leave the first bit and add the next bit. Okay. So after applying this division operation, you have to apply the XOR operations. Here 1 into 1, if common value is means 0. Okay, so here also both are common 0. Here difference 1. Here common 0. After applying this, the next bit is will be comes to picture. Okay, so you have to remove the first bit. Then now the fourth bit is came from the new bits from the dividend. Okay, so now 0 1 0 0 is there. The first bit is 0. No, if first bit is 0 means what I said, you have to multiply with the 0. If you are multiply with 0 means all the values are 0. So now you have to apply the XOR gate. Both the values are 0 0. Here difference 1. Here 0, both same 0. Both same 0. So after identifying, you have to remove this. Then you have to add the next bit. So next bit is 0. Okay, so next bit is 0. So here first bit is 1. So you have to multiply with 1. Okay. So 1 means again 1 0 1 1 it will come. 1 0 1 1. So now you have to apply the XOR gate. 1 into 1 0. 0 0 0. That both bits are common. The value is 0. Difference means 1. So we identified 0 1 1. The next bit is comes to the picture. So now we have to remove this bit. Remaining 0 1 1 0 is there. The first bit is 0. You are multiplying with 0. So all the values are 0. Now you have to apply XOR gate. Here you will get 0. Then you have to remove. Remaining bits are vary. So 1. Here also vary 1. Here also common. So both are same. So 0. So 1 1 0 we got. So these 1 1 0 will be replaced with these 000. That is code word. Okay. So this is the data word, whatever we kept 1001, and what is the reminder that will be keep with the data word, that is the code word. Okay, this is the CRC method. So how we can check it this data after sending from sender side? So this is the code word. Okay, so this is the code word we are sending from sender. So this once it is reached to the destination. Okay, once it is reached to the destination, how we can check it? So here both the conditions. Okay, so whatever data we received, as usual, same data we received, what output we are getting. If in case any data has have error, then what will be there? That we have to check. Okay. So same divisor you have to use, same method you have to use, but instead of 30, you can use remainder value. That is the code word. So after applying this same procedure, you can get 0 finally. The syndrome is all 0 means there is no error. Okay. The syndrome is removed. The remaining are considered the data word that is accepted. Okay. So here if you see there, in case 1 0 is changed, that instead of 1, the bit is changed to 0. Okay. So then apply the same divisor, apply the same division operation. Finally, we are getting 0, 1, 1. If it is not 0, then automatically we can identify that some error is there. So this data word is discarded. It is not accepted. Okay, this is the CRC method. So the same thing we can apply for the polynomials also. We can use a polynomial to represent the binary word. How we can represent? Each bit from the right to left is mapped into the power term. Okay, the rightmost bit represents 0 power term and the bit next to it 1 power term, etc. It will continue up to number of data words are there. Okay, if the bit of the value 0, the power term is deleted from the expression. So see here, this is the data word 1 0 0 0 0 1 1. So here we can start from the rightmost bit x power 0, x power 1, x power 2, x power 3, x power 4, x power 5, x power 6. Okay. What we said, wherever the 0 is there, we can just remove it. Okay, it is not required. But whatever remaining term is there, 1x cube, x power 6, and here 1x power 1 and 1x power 0. So anything power 0, 1. So here 1, here x, here x power 6. So this is represented here. So we can represent the binary data using expressions also. So when they are given the expression, we will take this division operation with the common divisor. Okay. So here you can use the dividend value. The dividend value multiply with some extra value. So example, you can multiply with x power 3. Okay. So x power 6 plus x power 3 is there. So here x power 6, x power 3 we are taken. So when we are multiplying with this value, what happened? So we want to get it here. What value we will multiply if I want to x power 6. So then I will multiply with x cube. X cube into x cube, x power 6. X cube into x power 4. X cube into 1, x cube. Okay. So here both are same. So 0. Here both are same 0. So x power 4 came. Okay. So if x power 4 means again we want to get x power 4. How we can get it? X power 4, if you multiply with x value. Okay, so if you are multiply with x, then x into x cube, x power 4, x into x square, and x into 1, x. Okay, so finally we are getting this value. So after applying the XOR gate, this will be removed. X square plus x is the remainder. So this is the code word, this is the remainder. We can add with the data. Finally, we are sending from this. The divisor in a cyclic code is normally called the generator polynomial or simply the generator. Okay. So now you know that how the CRC code is working and how to detect the error using the CRC code. Okay. So apply CRC. Find code word for the data word 100101 with the divisor 101. So how we can do it? So total number of bits are 4 plus 2, 6 bits are there. Here in divisor 4 bit is there. So we can add 3 extra bits again 100101. So you can add 000. So finally you can apply the division operations. Okay, what is the divisor? 1001. So now you can apply this same method. First value is 1. So you can multiply with 1. 1001. We can apply 0 0 0 0. So it will go out, then it will comes here 1. So first bit is 0, then you can multiply with 0. So if all 0, then you can apply the XOR gate here 0 0 0. So, here first bit you can discard it, no? 0. That is both are same means 0, no? 0 0 here 1. So it will be discarded. Then next bit will come here 0, like that we can identify the remainder. So whatever the data word is there, no, this 6 bits plus whatever remainder we are getting in the last, that will be added with the data word, that is considered as the code word. We have to work it out and come with the solution. We will discuss in the class. Okay. So now we are end of this lecture. So we can revisit the lecture outcome after listening to this video lecture. Now you can detect the error using the cyclic codes. If you know cyclic codes with the divisor is there means you can identify there is error is there or not. Okay. Thank you very much for listening this video. I hope you understood how the cyclic code is used. So next class we will discuss about forward error correction techniques. Thank you very much.